Hi friends, welcome to Srisai IT Hub. In this video of Core Java Programming, we are going to discuss the following topic: HashMap class with generic collections in Java Collections Framework. So first of all, we'll understand what is collection framework in Java. So coming to collections, it means collection of objects or group of objects as a single unit or single object in Java program. Then what is framework? So framework means it is a library which is provided by Java to work with Java collection of objects, and this library is available to us in the form of java.util package. In this package, we have different classes, interfaces, and its methods using which we can perform different operations with Java collection of objects. So in collections framework, we have collection interface, which is a top level interface or base interface for different classes and interfaces which are available in Java. So under this collection interface, we have four popular collections. First one, list collection. Second one, set collection. Third one, queue collection. And fourth one, map collection. So list, set, queue are sub-interfaces for collection interface, whereas map interface, it is not inherited from collection interface, but still it is part of java.util package and Java collections framework. So coming to some technical points. So Java collections is only for objects but not primitive data types. So if we store any primitive data type value like integer, character, boolean or floating, internally it will be stored in respective object type. Hence collections, every data is stored as object itself. To be more precise, it will be stored as object class object format, where object class is a superclass for all the classes in Java programming. So now coming to the class HashMap class with generic collections. So HashMap class is available in java.util package, and HashMap class, it is inherited from map interface. So coming to the map interface, it is not inherited from collection interface, but still it is part of Java collections framework and java.util package. So coming to the description of HashMap class, open the command prompt, go to your working directory and issue the command java-p -p java.util.hashmap. So hash map, so key value. So KV indicates they are generic parameters. So using generic parameters, we can specify which type of data need to be stored in HashMap collection. So coming to HashMap collection, it is inherited from map interface, and map interface, it is not inherited from collection interface. It is clonable as well as serializable, right? So coming to some technical points related to the HashMap collection. So HashMap collection is a collection of objects storing the data in the form of key value pairs. Example, key 1 is equals to value 1, comma key 2 is equals to value 2, comma key 3 is equals to value 3, etc. So here every key, it is mapped with corresponding value. So this is what is key value pair. So here all keys are unique and values can be duplicated. Its initial default capacity is 16. Its initial default load factor is 0.75, which is 3 by 4. So load factor decides the capacity of a hash map collection. For example, so the current capacity, initial capacity is 16. So 16 into 3 by 4, which is the load factor, equals to 12. So when we add 12th object, automatically the capacity will become double. So 16 plus 16, 32. So in HashMap, it does not have indexes. In HashMap, it does not accept duplicate keys. Values can be duplicated. So in HashMap, it does not preserve the order of collection because keys are stored based on hashing technique, and it accepts null value, specifically only one null key because no duplicate keys and multiple null values. So coming to the constructors and methods, it goes like this here. So in the description of the HashMap class, go to the command prompt and issue the command java-p java.util.hashmap. So we are going to use the default constructor with initial capacity of 16 and load factor 0.75, which is 3 by 4. And then we are going to use put method, put key value. So KV are generic objects. It decides which type of objects need to be stored as keys and values. And then we can use get key. It will return a corresponding value. And then access all the keys using key set method and all the values using values method. So this is the key set method and values method. So key set, its return type is set of keys with generic parameter, and values method, which is collection of values with v generic parameter. Right. So now on this set and key, we are going to apply iterator method. So iterator method can be applied on set and collection, whose return type is iterator cursor. And this is a iterator cursor with generic data type. So in iterator method, we have methods like hashNext, next, and remove method, using which we can access all the set of keys and all the set of values linearly from first to last. Right. So now coming to HashMap collection with generic collections. So first of all, the concept of generic collections, it is introduced in Java 5 version. And using this feature, it allows us to store collection of objects with respect to their specific data types. But internally, it will be stored in the form of its corresponding object types. And this is done with the help of generic data types or parameterized data types. So here, whenever we are creating the object of a HashMap collection, at that time we have to specify the generic data type using diamond operator. And by default, all collection classes and interfaces are generic collection compatible. Right. So in the description of the HashMap class, okay, we have key value. So KV here indicates generic parameters. So HashMap K, V. So how to store the values? So while creating the object, HashMap, diamond operator, integer, string. So all keys will be integers and all values will be string. And then object name, HashMap is equals to new HashMap, integer, string. So for example, if you are adding 101 Sai, accepted, integer string, 102 Ram, accepted, integer string, 10.6 Java, not accepted because it is float, string. And whenever we are accessing all the keys using iterator cursor, for example, ii.next. So ii is an iterator cursor on set of keys. No need to do downcasting. We can directly store it in X and use it in a program. Similarly, it.next. So it is an iterator cursor on collection of values. So no need to do downcasting to string. Directly we can store that in SS and use it in program. So the main advantage of generic collections is checked collections. It will check and store the data in the collection, and Typesafe collection. So when we access, we don't require downcasting. So while storing and accessing, JVM automatically performs auto boxing and auto unboxing. So this is what is the mechanism which happens in generic collections. So let us try to demonstrate this with a small program. HashMap-class example 8.java. So take a new page. First we'll write the comments. Program to demo HashMap-class with generic collections, and then import java.util package and take main class with main method and save this program in your working directory. So initially we will put generic objects into the HashMap collection. So HashMap integer comma string hm is equals to new HashMap integer comma string. So all keys are unique, all keys are integers, and values only string. So put 101 Sai, 102 Ram, 103 Ali, 104 Tom, 105 Pop, and print HashMap. So we'll execute till here. Right. Save the program. Come to the command prompt. So compile HashMap class example 8.java. Right. No error. So we also did not get the warning unchecked and unsafe operations. Run. So 101, 102, 103, 104, and 105. Right. So now let us try to put 10.6 Java float comma string. We'll get an error. Compile it. So error, incompatible types. Double cannot be converted to integer. Okay. So this is what is check and store. So check and store. Right. So now let us try to perform accessing objects. For example, so hashmap dot get of 101. So 101 is Sai. No need to perform downcasting. Directly store in string name1. Print name1. Similarly, hashmap dot get of 102. You will get string directly. Store that in name2 and print name2. So here downcasting is not required. Recompile and run. So name1 Sai, name2 Ram. Now let us try to access all the keys and all the values using set collection with iterator method. Right. So first we'll see set of keys. So on HashMap, I'm calling keySet method whose return type is set. I'm passing a generic data type integer and taking a reference variable as set of keys. So set of keys as integers. So on this set of keys, we are applying iterator cursor whose return type is iterator interface generic parameter integer and reference variable ii. Right. So keys are ii.hasNext, checking for the existence of next key in set of keys and return true or false. So true, come inside, and then ii.next, access that key, no need to downcasting, store that in X and print X. So save this, recompile and run. So 101, 2, 3, 4, 5. We got all set of keys using iterator cursor with generic parameter integer. Similarly, collection of values. So on HashMap collection, we are applying values method whose return type is collection of type string, generic parameter, reference variable collection of values. And on collection of values, we are applying iterator cursor, whose iterator method, whose return type is iterator cursor of type string generic parameter and reference variable it. So values are, so it.hasNext, check for the existence of next value in a hash map collection. If it is available, it.next, access that value, no need to perform downcasting, store that in y and print y. So save it, recompile and run. So these are collection of values accessed with iterator cursor without downcasting. So this is how we are supposed to work with hash map with generic collections in Java collections framework. Thank you for watching this video. Do like, comment and share this video, and also subscribe to the YouTube channel Sri Sai IT Hub. Have a nice day.